This is a very interesting question, and the answer to this question is A. Now, when sphere Y is positively charged and is placed in contact with sphere X, what happens is this positively charged Y will attract the electrons from sphere X to move into sphere Y. So with this, we can understand why sphere X, when it loses electrons or it loses some electrons away, sphere X from neutral, it should become positively charged. Now, how do we explain that despite receiving and attracting electrons into Y, how come Y still remains positively charged? Why did it not become neutral? Now, we can argue from the point of view of the whole system. So you just look at the whole system of X, metal rod, and Y in totality together. So this whole system, overall, how is the number of electrons there compared with the number of positive charge? We know X is started off neutral. We know that metal bar started off neutral, but we also know that Y started off being positively charged, meaning that there's lesser electrons. So all in all, in the whole system of everything, there is a lack of electrons in totality. So there's lesser electrons inside, there's lesser negatively charged things inside than positively charged things. So no matter how we shift electrons to and fro, right? I mean, from over here from X into Y, that overall there is still a lack of negative charges. So with this idea, we can then reason that no matter how much electrons we shift over to Y, it will never be neutral. So end up both the objects X and Y, they will become positively charged. Now Y, sphere Y will become less positively charged than before because it has received some electrons over from sphere X, not enough to completely neutralize Y, but that's why it remains positively charged, but not as much as before.